Hello everyone. Today we are going to explore a beautiful inequality involving the exponential series. We'll prove that the partial sum of 1 plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over n factorial is always less than 3, no matter how large n. This is a fundamental result that connects sequences, series, and numbers. This statement, here we have the inequality to prove for all n integers. Prove that 1 plus 1 over 1 factorial plus 1 over 2 factorial plus so on plus 1 over n factorial less than 3. This is the partial sum of e to the h at x equals to 1. We know that e equals to 1 plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial and to infinity, approximately equal to 2.71828 less than 3. Since the partial sum are less than the full sum, the inequality is true. But provide term-wise comparison. As the one bounded each term, the key inequality for k greater than or equal 1, we have 1 over k factorial less than or equal 1 over 2 to the k minus 1. We know that the k factorial equals to 1 multiplied 2 multiplied 3 and multiplied 10 is greater than 1 multiplied 2 multiplied 2 multiplied 2. K minus y 1 times 2 equals 2 to the k minus 1. Therefore, 1 over k factorial is less than or equal 1 over 2 to the k minus 1. We can use geometric series 1 plus 1 over 1 factorial plus 1 over 2 factorial plus so on plus 1 over n factorial is less than 1 plus 1 plus 1 over 2 plus 1 over 3 plus so on and plus 1 over 2 to the n minus 1. Sum of geometric series we have this we can write the sum of geometric series 1 plus 1 plus 1 over 2 plus 1 over 4 plus so on and plus 1 over 2 to the n minus 1 equals 1 plus 1 minus 1 over 2 to the n over 1 minus 1 over 2 equals to 1 plus 2 multiplied 1 minus 1 over 2 to equals to 3 minus 1 to the 2 1 over 2 to the n minus 1 less than 3. So after the combining the results, we have that 1 plus 1 over 1 factorial plus 1 over 2 factorial plus so on plus 1 n over n factorial is less than 3 minus 1 over 2 to the n minus 1 less than 3. So the final result we can write that 1 plus 1 over 1 factorial plus 1 over 2 factorial plus so on and plus 1 over n factorial is less than 3 for all positive integers and equality never occurred. The sum approaches approximately equal to the 2.71828 as n goes to infinity. Although another approach using using the known value of e exponential series, we know that e equals to sum of k from 0 to infinity 1 over k factorial equal to 1 plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial and so on. Also, we know that the partial sums are increasing if we assume that Sn equals to sum of k from 0 to n 1 over k factorial, then Sn less than e for all n's. So e is less than 3, Sn is less than E and less than 3, then Sn is less than 3. So we can write that 1 plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over n factorial is less than 3. And here we have the summary of presentation. The statement is 1 plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over n factorial is less than 3. For the proof of the statement, we can use the termwise comparison that 1 over k factorial is less than or equal 1 over 2 to the k minus 1, and we can also use the geometric series that this sum is less than 3 minus 1 over 2 to the n minus 1 is less than 3. And we can use that Sn is less than E less than 3. So when Sn goes to when n goes to infinity, Sn goes to E, and E equals approximately equals to 2.71828 is less than 3. Thanks for watching. See you in next video.